We know of the deforestation that has gone on, and we also know that currently there are some rivers which were drawing their source from the the bigger Mau. Those rivers are now dying, natural death. And so we cannot overemphasize, it is something which is critical. And that's why we still have our icon, Wangari Maathai, who championed seriously the planting and saving of trees, because she said that trees are actually the source of life. But you listen to some of our politicians, they will tell you, they actually ask whether it is the tree that brings rain or the rain that brings tree. I don't know whether you have heard those questions when we are talking about conservation. So it is something we need to have an honest discussion and conversation on as we look forward for the future. So in this, the key things here: use of natural resources, minimize toxic and pollutants, reduce emission of waste and pollutants, limiting adverse impact over the future generation. That is the focus. So then what is the goal of sustainable production and consumption? Is to produce more while making use of as much or as little resources as possible. So there is therefore need to implement sustainable use of resources during processing, during production, to reduce the negative impact on the environment. I think we have fallen short in that statement of talking about during consumption. Or don't you think consumption has got a role to play when it comes to sustainable management? And one things that we have been struggling with are issues of how do you deal with packaging. Right now, you just go along the roads, even if you are traveling just to Nakuru, you will find a lot of these bottles thrown along the road. They didn't go there themselves. Somebody consumed and then found that it is no longer useful and just dropped it. And some of us who are driving are very notorious as well. You take your water or juice and then you don't care. Sometimes I see people throwing things outside their window and I ask myself, did they employ somebody to come and pick it? That is the consumption level. So the consumption level also has a negative impact. So we need to have that conversation from the production, processing, then consumption. There is a lot that we can do at the consumption level. So the key natural resources of our main focus, especially in this project, is water, energy, and of course not forget waste management. And of that, the adoption of best practices are important to assure SCP. So that is the focus. And this did not just come from anywhere. If you look at what we are now calling the Sustainable Development Goals, which are actually championed by the UN, this is now the world level, the farthest you can go. If you look at goal number 12, it talks of responsible consumption and production. And all this is surrounding what we are talking about, which some people have given the name Switch Africa Green. So if you look at the goal itself, it is divided into several units. You can see if you begin with the first one, you have implementation of SCP, and then you have got, you need to achieve sustainable management of resources. Then you need to have per capita global food waste being determined and achieve sound management of chemicals, especially that are being used in production. And of course, reduce waste generation through the PRRR, which we are going to look at. Then encourage adoption of sustainable practices. It is championing all that. Then promoting sustainable public procurement and ensuring info lifestyle in harmony with nature. Right? And so all these are surrounding the sustainable or responsible consumption and production. So it is something that is coined out of the greater global goal of responsible consumption and production. So it is something which is, it is a conversation which is going around all over the world. And we cannot afford to be left behind as a nation and as a component which is making very important contribution in the economic well-being of this nation. So that is the introduction I wanted to bring. And so I want to welcome you to proceed with what we found out in our scenario, so that when as we continue to go ahead, we can be able to see how to get out of it. You agree?
Good morning. So, for those who we started with back in 2018, we did a survey across Western, Central, and Nairobi, Kenya. And so far, we found out that although results are showing good environmental practices, still, the awareness, you may know that it is wrong to discard of maybe a used mask or packaging material, but then, what is the practice? Most of us are ignorant, rather. We are like, we don't care. I get what I want after I use, I dispose of as I wish. What we don't factor in is the future generations. But on a nutshell, because our project is targeting the MSMEs, and we found that most of us are like our businesses are around fruits and vegetables, and these are for local consumptions. And one of the things is that with the fact that we don't have some of these international standards means we cannot export, okay? And it doesn't matter, I guess, as we are here, we are also small-scale processors. We have a group in Eldoret called Massive Foods, and it's just a small SME, but has got compliance to many international standards, and they can be able to export their produce, and we guess that you will as well reach there at one point with the ISO certification. So although there is high demand for, let me just move my screen a bit. So most of the response is high demand for this, but again, we may not have really the capacity to produce this. For example, we find that most of the products that are produced under these, the guys we surveyed, are fruits and veggies. Others, we talk of a mixture of businesses. For example, someone could be doing fruits, vegetables, but besides that, they're also doing maybe because partly the cost of producing them. And you find whatever can also reduce your costs. And therefore, that is where we are. Like 60% of us are that. And to ask those who are here, that is what we are doing. Standardization and certifications, none of us is ISO certified, okay? This ISO certification, helps 35%. Having that, assuming And it means our markets are not fully set. So the thing is, we have KEBS as a partner here, and for those required, even if you have scale processing, you can get you have followed. And in terms of audits, for those who have the KEBS mark, you can see again, only 25% or less get this. That's just a quarter. And that really limits the potential of MSMEs. And that is why I want to encourage you that as you are part of horticultural projects, be as close as possible, get in touch with the KEBS partners who are also part of the project. And then you will get your standardization marks, you get your audits, you have your books in current form. And with that, you can also work easily with the ISO. We said the ISO certification is a lot of standardization required. There's a lot of documentation. Audits will be part of it. And maybe it's good you start with the KEBS. So one of the things we found is that, I don't know, for those who are here, how many of us have got one? Yes. I've been told that not all of us are processors, but if whether a processor or not, we can even think of it. How many times do we look at water records, even at the household? Do we really mind? Or we just consume water? You get the water bill, but whatever way it's being used, we really don't care. The energy again, for our processor, these are very important things for sustainability of what you're talking of. Because if the effect is on the environment, you need to have ways of knowing what am I using? What can I do to reduce this? For example, you can see if it's during the day, I have my bulbs on, that is energy you're using. What if you install a solar panel, for example, to give you lighting for the day? So we also have poorly installed water and waste management. And you find that, yes, you have a small scale processor, but again, how you handle your waste, water, waste treatment, according to regulatory framework you had yesterday, before you discard off even the wastewater, there is a provision that it should be, you should ensure that the water you discard to the environment does not harm the life at the end of it, for example, the marine, because all these water systems end up in the large waters. And even if we are generating our waste, we should also treat it. But most of us, anyway, because we are small scale, or rather, maybe are also people practicing this at home, you find that you don't care. Waste is waste, okay? That's the practice here. If you go elsewhere, like Professor will talk about waste management. In other countries, waste is segregated. If it's plastic, it's glass, it's metal. But here we just discard all manner of things in the same maybe pit, and you find that it's also part of what you really require to learn. For example, for those with the production, you may need to install systems that indicate, for example, waste plastics will be discarded here, waste metal, waste glass. That helps you to separate out your waste so that those that are biodegradable can be easily separated out. For example, if you are a vegetable processor and you want to produce biogas, and then you mix all your waste, all manner of waste from the production floor are mixed. Will you be able to generate what you need really? No, that will reduce the efficiency. So the sustainable consumption practices are quite low, and that's why we are trying to create this awareness amongst us. And yesterday, you remember we said it starts with you. It's one person at a time, right? Starts with you, change the mindset of the next person, the next people you're working with, tell them maybe this is what we need. And partly, whatever we are talking of here, we've given you some reading manual with you on your desk. You look at them, it will be of great help on how you can approach this. It may seem hard at first, but again, it really is a matter of going forward and saying, this is what I want to do. So where do I start? At least you even use somewhere to start using what you have before you. So in relation to that, we wanted to see what is the consumer side. You know, at the end of the day, whatever we are doing, the consumer is the key person, right? But again, if you come to here and tell us, now, my friend, I have a product that is packaged in a material that has been recycled. But now, because it's recycled, I would like you to pay a little bit more, maybe 10 shillings for the extra processing. How many will be willing to do that? Very few. Because consumers look at prices first. And if you want to be considerate of the environment, anything environmental has been shown to be a bit costly. Let's talk of organic foods. How many people buy organic foods? As much as we want to eat them. But what is the disadvantage with organic food for, let's say, an average consumer? The price, right? It's relatively highly priced. If you talk of the organic yogurt, the bio yogurt in the supermarkets, a small can of about 100 ml costs way more than the normal yogurt that is just flavored. And someone will just say, I would rather buy this because the quantity I get for the equal amount of money is high. So a consumer will always be driven by that. And as a processor, we are in business here, right? You also want to maximize. As much as plastic has been banned, but it is more convenient because a consumer can afford, people would rather do what? Go to Uganda, maybe through the border, come with the polythene again, right? Rather than use what is recommended. So prices have got an effect, but again, it affects the whole chain. Again, if you come as a small scale processor, you want to compete the big guys and your product is relatively high. What happens? You'll be crushed, okay? So it's a delicate balance, but again, you can have your niche market. You say, hey, for me, I'm processing. What was the king here? Just a normal tomato. So again, quality and price are relative. Expensive. The less the quality, the less the pricing. So although 40% of consumers would prefer environmentally conscious products or those that will have got little effects, you find that we don't buy really green products. By green products, I don't know how many of us have heard of green products here, or sustainable products rather. I don't know the words you're using. There's not a green bottle. Okay. So when you go to supermarkets, there are those consumers who look for green products. It's not a common practice here like it is in the Western countries. If you go to Europe, for example, you're going to a supermarket to buy a bottle of water. Consumers there are more conscious of the environment. They look for water packaged in a recycled bottle first. And then if there is no that, that's when they go for the other option. So for this, that's a consumer who is aware of what a green product is. A green product is a product that has been processed, packaged in materials that are less harmful to the environment or recycled, okay? And one of the things with the green product is also they must have this carbon print or carbon effect on the environment. That is because of if you look at a product, for example, the bottles of water before you, as it was being produced, there was generation of gas that is going to destroy the ozone layer. So there is what we call the carbon footprint. Maybe Prof will talk about it more. So if you look at that, in Western countries, you have to declare how much of this has been used. So for a consumer who is a green consumer, they will rather look at, if I'm buying this water and it had the least energy use to produce, I would rather buy it. So the thing here is that we don't emphasize that. And even if it's emphasized, maybe we are not even aware of it. Because there are those labels that they're there, maybe they're recycled. If you go to supermarkets, how many people go for that? There are very few products actually with emphasizing that you have processed this product from recycled material or biodegradable material. So the trust on eco-labels are significantly low. When you are told this product is organic, how many of us trust the sellers? We just always just say, it's our don't know, but we'll just buy, but our trust level is usually low. We know ourselves, right? Like yesterday, we were talking of the vegetable producers who would rather use sewer water without treatment, industrial discharge. But they'll tell you, my vegetables are what? Are produced in the most environmental friendly condition as possible. They will not tell you the truth. The thing is now we've been conditioned to that. Hata hapa when we buy, even if you see kama hii, it's written there recycled bottle, you just say this is a lie, okay? For one, we don't even see whether there is recycling here because it's not a well-elaborated industry anyway. There is also a lack of information, adequate information, especially on what sustainable consumption and production practices are, and also unavailability. One of the things is that with unavailability is that if you want to do green products, then you'll be targeting few consumers because you want to associate it with a bit of costs, which most people may not really want to look at. So what are the critical needs as of now? Maybe will be the ambassadors as we live here. We need to sensitize more processors and consumers on the staff on what the importance of water, waste, and energy conservation, or rather proper management in order to ensure that the environment you're working in is also left in good conditions for the future. Remember, the whole concept of this sustainable consumption production is not about us. We are all in a passing phase. There are future generations. What will they find? The best case to put it is, let's look at the subdivision of land here. Okay? What we've done here. If you go to Western countries, land for food production remains intact. There is no subdivision. If you think of it, the way we subdivided our lands, what do you think the future generations will be feeding from? How will be the food security status? It's going to be critical because beyond this, you go maybe to my rural area and look at them, and the land has been so much divided, the family members are increasing by the day, income is also low. All these people need food, but the land you are in will never be enough. So once we are also destroying our land here or the environment here, maybe COVID has taught us a good lesson. Home is where you need to be, right? Because hata tumeona sahi juzi that if you are not well organized, you remain with your problems. If your health facilities are not good enough, you die with your people. So it is going to be the same because there's towards the future, war on water will be one of the worst things, and that is partly will be contributed by the actions we have now. So we need to do that. Be passing the information to each and everyone we get. We are trying to continue training and facilitations where we can, for example, through HotGreen. There are also other projects that are really working towards that to ensure that the ISO standardizations are promoted because they are really thorough and they really, before you get the ISO certificate, you've got to go through a lot, and there's a lot of training. For those of us who will continue with the exercise, when we follow up, you realize it's way more complicated, or rather there's so much information, so much compliance required. And therefore, to ensure that there's sustainability, we need more stakeholders. We're just one institution, maybe with the government in, but it's a multi-sectoral approach. If I'm talking to you as a processor, there is a consumer, there is the authorities, research bodies like us, then there is the regulatory ones like the NEMA, KEBS. But again, to be realistic, we always go back, our systems are corrupt. Sometimes you'll be found by a KEBS guy that you're not compliant. But what happens? You do what? You corrupt your way back. Sometimes you see products withdrawn from the market, maybe due to food safety issues. But again, 2-3 months down the line, they are back. You know, we have this culture in Kenya whereby if today a scandal is found, let's say for company X, it will be all over in the media, but after that, a few days down the line, no action has been taken and the guys are back in business. But that's what we are saying. We don't need to be that. We need to be people who are considerate of the other human beings. And maybe we can change this by the time I believe we are leaving, or for those who, as we continue this work, you continue to learn more on these sustainability concepts. There's so much detail. There's so much publications we've done. We'll send you to our website. You can download what, because these are already out. We have a policy brief on this, the consumer's approach towards sustainable consumption practices. It's detailed. That's just a brief summary. I guess that is the end of it for now. I'll invite Prof to continue on energy and water use and management. Thank you. Any question? Okay. Thank you. Yes, you're good.
Where is it? Yes. So, good morning. Oh, it on? Yes. Good morning, ladies and gentlemen. Yes, my name is Michael Okoth. I was introduced earlier from the Department of Food Science, Nutrition and Technology of the University of Nairobi. Now, I'm going to give a presentation on two aspects of sustainable production and consumption. One is energy, sustainable energy use, and the other is sustainable water use. The focus is on vegetable processing, fruit and vegetable processing factories. Now, fruit and vegetable processing factories are diverse. So we have a number of different products that are processed. And we also have diverse capacities. So we have micro industries, and we have small scale, we have medium scale. MSMEs is what we are dealing with. And they obviously differ in the level of technology. Some use a very basic processing technology, and some are quite advanced, especially when you go to the medium scale production systems. Now, energy, here we are talking about two forms of energy. One is thermal energy, basically heat, and the other is electrical energy or electricity. Now, as you know, heat is required for raising the temperature, or if you like, for heating materials. And in our fruit and vegetable processing industry, the materials, of course, are the products, the fruits and vegetables. These may have to be heated directly for purposes of preservation or just to facilitate processing. Now, in processing factories, heat is also required for cleaning operations. As you know, very high hygienic standards are expected in food processing factories. And therefore, cleaning and sanitation is part and parcel of fruit and vegetable processing. So a lot of time, a lot of resources are expended on ensuring that the hygienic conditions, the required hygienic conditions are met. Now, as for the heat generation, fuel is always required to generate heat. There are a few cases where there is direct use of electricity for heating, but generally that is very expensive. So therefore, usually there is use of direct fuel for, that is burnt, or rather there's combustion of fuel That may be oil, maybe gas, or maybe fuel wood, And for electricity, in most cases, electricity comes from the national grid, that is KPLC power. But there are processing facilities that are located in areas without power from the grid, and these have to generate their own electricity. And whether you are generating your own electricity or getting it from the grid, it costs money. Electricity costs money. And you can generate, of course, electricity from generators that are usually fired by oil, diesel, mostly industrial diesel or some other diesel, or some other fuel like gas. But increasingly, people are turning to solar energy for electricity generation. So that is renewable energy that for a while has been rather expensive in terms of capital investment, but is increasingly becoming more and more affordable. And indeed, recently, you may have heard that KPLC is worried that many of their customers are switching to solar generated electricity, and therefore their revenues are decreasing. Now, I am now talking about specific energy conservation measures, and I'm starting with boilers. A boiler is used for generation of steam, and in many processing factories, the heating is not directly from the fuel, but via a heating medium. And that commonly used heating media are steam and hot water. Steam and hot water. Now, these can be generated. Even for very small scale operations, you can generate steam. You can also generate hot water using very simple processes. For example, for hot water generation, you may just boil water in a large sphere using wood or gas or even electricity if you don't mind the cost. But for fairly large operations, where large here is very relative, talking even of some micro scale factories or small scale or medium factories, boilers are common equipment in food processing factories. And selection, and the boilers use, of course, the various types of fuel that are mentioned to generate steam. And selection of appropriate fuel increases boiler efficiency and reduces fuel cost, where efficiency here refers to the percentage of the thermal energy in the fuel that ends up in the steam that is generated. And proper sizing of the boiler at the design stage, or indeed at the time of purchase of the boiler is important because if it is too big, then capacity utilization will be low and efficiency will be reduced. And there is need for insulation. Heat is lost from boilers, from the surface, boiler surfaces, through what is referred to as convection and radiation. And insulation is recommended, proper insulation. Now, steam pressure needs to be controlled, because the higher the pressure, the higher the energy consumption. And therefore, you only generate at the maximum pressure that, rather the minimum pressure that is needed. Generate at the minimum pressure that is needed for your operations. And with regard again to efficiency, fuel efficiency, the ratio of fuel to air, the ratio of too little air in complete combustion, or you have too much air and you end up with a lot of air going out through the chimney and carrying with it a lot of your energy that you would rather use for productive purposes. And there's something called blowdown, that is the release of some of the hot water inside the boiler periodically or even continuously to minimize the solids inside, the buildup of solid materials inside the boiler. And there's something called draught loss, when the boiler is not running but has hot water and steam, and there is continuous flow, natural flow of air through the boiler. So that wastes energy. Now the steam condensate once steam is utilized for heating, it is turned into a condensate, which is really hot water. And this hot water needs to where are we? Is I there? Or I go back? That's where I was exactly. So return of that steam condensate to the boiler has to become part of the boiler feed water, saves energy. And of course, maintenance of the boiler, proper boiler maintenance improves its efficiency. For example, when soot builds up on the heating surfaces, then the transfer of heat to the water, and therefore the utilization of that heat for steam generation is reduced. I've already talked about insulation. This now a steam system. So having generated that steam in a boiler, it has to be distributed to the end users. So we are talking now about the steam distribution system. Steam distribution system. Of course, this is a piping system. So we have steam pipes that distribute the steam to the end users. And insulation again is recommended in provision and maintenance, proper maintenance of steam traps. Steam traps are installed on the steam distribution line after the equipment that is utilizing the steam, so that only the steam condensate is returned to the boiler. So a steam trap does not allow steam that is unutilized to escape. And leaks, of course, are obvious. These should be prevented. And I've already said that the condensate should be returned to the boiler. Again, insulation, minimization of leakage. and efficient control of temperature and time. So this has to do now with the actual processing operation, the processing equipment that utilizes the steam. So the product temperature or the target temperature should not be higher than is necessary. So the lower the temperature, the less the steam requirement. And then time is processing time. For example, if you are cleaning, our cleaning operation, you can clean for 20 minutes, you can clean for 30 minutes, you can clean even for 1 hour. And now, of course, the longer you take, the more energy, the more steam you require for heating the cleaning solutions. Yeah. And then there's the issue of recovery. Yeah. Recovery of heat from hot streams and utilization of that heat for heating, for example, cleaning water, equipment cleaning water, or boiler feed water. And I've mentioned the issue of soot, cleaning of heat transfer surfaces. Yeah, not just soot in the boiler, but even the end users. So that heat transfer surfaces need to be regularly cleaned to facilitate heat transfer to the product or to whatever material is being heated. Yeah. And where there is frying operation, then of course oil is used for frying, and this oil degenerates, and at some point it has to be replaced, has to be discarded. And the suggestion here is that it may be used as a biodiesel fuel in a diesel engine. Now we are moving to electricity. And electricity is mostly used for powering equipment, for powering machines via electric motors. And of course, it is also used for lighting. I mentioned a few cases where it is used for heating, provide heat, like producing hot water or steam. And so there are many measures, many energy-saving measures, where the energy now is electricity. So beginning with electric motors, you can install energy-efficient electric motors. So some electric motors are inherently more energy efficient. So when you purchase, you look for the energy efficient ones, even though they may be a little more expensive, but that extra cost can be recovered within a fairly short time. Yeah, and again, the sizing, the maintenance, all these affect the efficiency of the energy consumption of these electric motors, the sizing of the motors. If they are oversized, then the capacity utilization will be low and efficiency will consequently be low. And drive systems are recommended of the opportunity to install adjustable speed, then there will be considerable energy saving. And there's something called power factor, basically efficiency of electricity utilization. So idle motors should be switched off, and there's something called power factor correction, which requires installation of capacitors in the AC circuit. Now, pumps are very common in food factories handling liquids, whether the liquid is water for cleaning or directly for processing, or the liquid is the food product itself, like a food. Pumps are really have many pumps and of course interconnecting pipelines. So that is what you see most, because of course there are machines and other equipment. They are also connected, are served by the pumps and by the pipelines. And so therefore it is a major consumer of electrical energy. Pumps are major consumers of electrical energy. And the issues are really the same: proper maintenance, proper design, so that the right size is installed, installation holding tanks, so that the pump capacity can be reduced. That means that you can have a smaller pump, but you have a holding tank so that you are not always pumping, or you are not pumping as required. And control systems are required so that the pumps can be switched on and off depending on the desired capacity. Yeah, depending on the desired capacity, and especially where there are multiple pumps working in parallel. So if you have, say, three small pumps, and when their desired capacity is high, then you operate all of them in parallel at the same time. And what is meant here by having multiple pumps working in parallel, and of course that operation can be automated. So if you have you can have a proper control system that will detect, or when only two, or when we need all the three to operate at the same time. It's not moving. Oh, now it is there. Have I gone too far? Yeah. Then installation of newer, higher efficiency pumps. Again, there are those that are inherently more efficient. And if they are newer also, then they are more efficient than the old ones. So there has to be a machinery replacement policy within food processing organization, so that you do not go on operating a machine that has long exceeded its useful life, and therefore incur very high operating costs. Yeah. And so I've talked about sizing, avoiding throttling of delivery line. Yeah, instead of having a valve or the delivery line to control the capacity of the flow rate, it is better to have an adjustable speed pump drive. And even the pipes through which the fluid flow is pumped need to be properly sized. If they are too narrow, then resistance to flow is too high, and higher energy consumption is incurred. Now, a common feature in food processing factories, especially in fruit and vegetable processing factories, is refrigeration systems. So there is, because of the perishability of these foods, it is almost always necessary to maintain low temperatures, either by cooling these foods directly or by storing the foods in a cold room or even a refrigerated cold room. And the refrigeration systems are notorious for their very high energy intensity. They consume a lot of electricity. And therefore, a lot of thought has gone into optimizing the design and operation of refrigeration systems. And so therefore, the list of recommendations on these systems can be very long. I just highlight a few things. And in fact, most of these can be found in the guide that you have been given. So again, controls are important, efficient control. Now, cooling load reduction, meaning that you want to perhaps pre-cool, and that is mentioned a little later there. You can use chilled water to cool fruits and vegetables before loading them into a freezer. So that reduces the cooling load that has to be provided or carried at the refrigeration system, and removal of residual water on products before freezing. So, of course, you normally wash fruits and vegetables, and when that is done and they are taken for freezing with surface water, a lot of surface water, then that surface water has to be frozen also, and that requires energy, and it is unnecessary utilization of energy. Yeah. So you have to avoid infiltration of warm air, avoid or minimize heat sources inside a cold room, and adjustable speed drives. Yeah, because refrigeration systems have mostly use compressors, and an adjustable speed drive would help in saving energy. There is something called as a condenser in a refrigeration system that needs to have clean surfaces to improve heat transfer. Yeah. And for, again, the type of air circulation fans for condensers can also make a big difference. So there are types of fans that are more energy efficient than others. Lighting, of course, is found in every processing factory. Light is required. You need to see what you are doing. You need to be sure that the surfaces are as clean as expected, and you can't have that assurance without being able to clearly see the cleaned surfaces. So you need adequate lighting, and the lighting of course is usually electrical, and so the lights need to be turned off. That's a very basic requirement, and much of the energy saving program is on just sensitizing workers to turn off lights if they are not required. There are energy saving light bulbs, which I'm sure we are all aware of, and therefore one has to go for the most efficient light bulbs, and one should make efficient use of natural light during daytime. Efficient use of natural light during daytime. This has to be taken care of at the time of the design and construction of factory building. So generally, these are some of the practices. There is the need for monitoring, indeed measurement of energy consumption, whether thermal energy or electrical energy. Total energy used per day needs to be known. You need to know how much energy you are using to produce, say, 1 ton of your product, and therefore cost of energy per unit weight of your product. So if you have these data continuously, then you can clearly see, you can be able to monitor your progress. You can see where you are. Indeed, first, their status, your current status will be known, and if you institute some energy saving measures, then you'll be able to monitor the progress that you are making, or the difference that those measures are making. So that is my presentation on energy conservation. Do I move directly? Okay.
So maybe before he moves, we could take any question or clarification. I know when we do this, we only think of factories. But I have a very good example. When I first took this information, I went to apply it at home. So I began recording the electricity consumption daily. Okay. I realized that I was using a lot of kilowatt hour. Then I started looking at, why am I losing? Where is the most cost? I tried eliminating everything. Eventually, I narrowed down to my refrigerator. That had taken more than 10 years, and it was now consuming more power. I called the person preparing to look at it. He raised things. It never worked. After replacing the oil, replacing the refrigerant, it never worked. So I said maybe probably this is the time to change it. So when I went to buy the next one, I was very keen on the consumption, because the original one I didn't even care. I didn't even know there are issues of consumption rate with the refrigerator. So when I went, I looked at, there were 6 refrigerators at Carrefour, but they had different costs. Then if you look at the back, you will find one of the energy savings has got a green tick, but it will cost you more, just a little more. So when I took that and I went home, the consumption went down from consuming 3 units per day, 1 point something. You see that one is now reduced by cost in the long run. So I applied this just in the house, but it is not only limited to processing companies. It can also be applied to if you are really dealing with the heat reduction in the field, especially those who are doing fresh produce. This is very important information. So I don't know whether there is any comment or clarification before we take a tea break. Okay. So we can take a break of, I think it is now 10:18. If we can come back by 10:40, 10:45, that is 25 minutes. Or are we able to make it within 20 minutes? Hello? Okay. If we can make it early, is the better. So within 20 minutes, we should be back. So those who are online, we are taking a 20 minutes break and we shall be back with water efficiency. Thank you.
So,
It means you should be taking tea already. Or is it not there?
yes.
Why are you not a good man?
Why?
We agreed you were to meet. You disappeared in thin air. Mm. Eh. Mm. Uh-huh. So you are enjoying and you kept me waiting. Mm. Mm. So what are you saying now? Again, the morning started very difficult. I had first meeting at 8, the second one at 9. It is just I have just taken a break. I will have another one at 12. Then I have another group of people I'm taking to Kabete for a tour. That I can only look at it in the evening. So, hi. Okay.
I should have started. That was my. Leo tuko wangapi?
Tuko 15.
Oh, just like yesterday.
Yesterday was 14.
How are we not 15?
There were 9 rather 9 participants. They were 10.
Oh, we got someone extra there. I guess. Yeah. Then we'll need to. No. So now we have more because okay, who was replaced yesterday's the two ladies. Okay, so we replace one of the two drops. What? Yeah. We need to form your photo. Is your back to yeah, the military dog. So how do they live here? How will they live? Standard college.
To know how many
Yes.
then I can carry some, and then you can get another.
Okay.
Yeah. Kumbe ikichukua watatu,
Watatu unaweza beba?
unaweza beba watano.
5. So already those are 8.
Wameenda kiasi.
Watano plus wewe ni 6 hivyo, si ndio? I know proper kuja na gari yake like you may not be headed there, right? So
We may not depend on them.
no. Linda drives it.
Linda will disappear.
Oh yeah. So we have
five
what?
of them are gone.
5 are gone already. See, Linda and Prof now.
Linda,
Prof now. Yeah.
those
We are just 15.
how many?
15. So we remain with 12. You carry Seattle huko kwa hiyo, so 6 plus 4. So we remain what? We are 12, 6. Uba mbili.
So
Okay.
and not two.
No problem.
But I know some of them are driving.
Oh, okay. There's also one lady ataenda, so maybe hata itabaki one Uber.
Not all of them will.
Yeah. So as soon as they're done with lunch, we tell them what's our lunch for them. I guess we don't have much remaining. Do I tell them that?
You can serve it at 12.
Okay. Yeah, because now if it's just 12,
By 11:30, then you can get another 40 minutes.
by 12:30.
Yeah. You can serve it at 12:30 as well.
Okay. Let me just go there and.
No, I think I want to check something else.
Oh, okay. Kuna chai hapo eh?
Yeah.
Wewe ndio ulitumwa? Wana Sara. Oh, great. Umetoka wapi? He. Okay. Karibu eh? Kunywa chai, tuliambiwa ulitoka 6. Ndio alitoka Nakuru.
Good. Is the So, welcome back to this session where the concern is still efficient utilization of resources for fruit and vegetable processing, and the resource now is water. Good. So, water is essential in fruit and vegetable processing operations. It may be used as an ingredient, meaning that it becomes part of the product that is being processed, or it can be used for cleaning and sanitation operations. There's cleaning of floors, walls, and equipment surfaces, and can also be used for cleaning of the raw fruit and vegetable. So the fruits and vegetables often come with dirt, and they have to be cleaned in using clean water, sometimes even using a disinfectant such as chlorine in that water. And water fluiming is where the material is being transported by water, by a water flow. So like if you have a canal and your food material is there, this happens a lot in the coffee industry, where the coffees are conveyed by water. That is what we mean by water fluiming. It is of course required for cooking, for an operation that is referred to as blanching, which I think many of you are familiar with. That is really mild heat treatment. And the water comes from a variety of sources. So you will of course get your water from the most appropriate source, or perhaps the nearest source. And the water almost always has to be treated to meet the required quality and safety or utilizing water efficiently. One is that the demand for water often exceeds the supply, and two, climate change and variability makes the adequacy of water supply uncertain. And three, water is a major cost item in a fruit and vegetable processing factory. And reduced water consumption results in less energy for water pumping and treatment. And reduced water consumption results in reduced wastewater discharge volumes and treatment costs. And last but not least, the recovery and recycling of hot water leads to reduced energy consumption. Now, food processing companies, or if you like, food business organizations need to have strategic water management programs. They need to have strategic water management programs within their operations. And strategic water management program should have clear goals for water saving, and the staff need to be committed to this program, so their commitment needs to be established, and adequate resources and budget should be devoted to management. Part of this management program water, all end uses of water. So you must document all end uses of water. What do you use water for? Go to the details of water use. Where is it used and for what purpose? Then you need daily or hourly water consumption rates for all the water end users. So this requires measurement of water usage, measurement of water flows or water volumes, or weights. And one should start by documenting the existing water efficiency practices. So what practices are there that favor efficient use of water? And following the water audit, appropriate water saving measures should be identified. Appropriate water saving measures should be identified. And secondly, the identified water saving opportunities should be subjected to cost-benefit analysis. In other words, each of the water saving opportunities or each of the potential water saving investments need to be subjected to economic analysis to see whether or not, or to identify which of those suggested measures are economically viable. They must, of course, first be technically viable before we subject them to economic viability determination. And three, prepare an action plan and implementation schedule for all feasible opportunities. And of course, you implement the feasible opportunities, and as you implement, you track the results. You track the results. This is monitoring and documentation, that you track the results and you publicize successes. Publicize successes. That is within your organization. You publicize the successes so that people are aware of the successful measures, and so that they become more enthusiastic about implementing those measures. Now there's something called good housekeeping. Good housekeeping. So there are measures or water saving measures that are described as housekeeping measures. These are measures that require very little or no investment. Measures that require little or no investment. So there are things you can do that do not require any investment. You don't need money. It's just change of practices. So you have the same staff doing the same things, but they just do them differently with a view to saving water. So one of these is a regular inspection and immediate repair of any leaks found. So the inspection may not cost money, the repair may cost money. It depends, of course, on the nature of the work required. But it might be perhaps little money compared, for example, to installing a new equipment or machine. Now, replacement of faulty valves and fittings. Yeah. Switching off water hoses. So these are hose pipes. Switching off water hoses and sprays when not required. Water hoses and sprays are used for cleaning operations, and it is not unusual to find water running for extended periods of time from a hose pipe when no cleaning is taking place. So usually a hose pipe is very long, it can be quite long, comes from the water source, and it's used for cleaning the whole factory floor. And so the tap or the valve for switching it on and off may be very far up the wall. And when the worker completes cleaning, sometimes just dropped down. And perhaps with the intention of shutting it off later, a little later, but it may be forgotten, and the water then continues to run needlessly. But waste that should be avoided. Measuring and optimizing water flow rates and reduction of the amount of food waste falling on the floors. So careful operation to minimize the amount of food waste falling on the floors will reduce the need for cleaning, and therefore the quantity of water that is required. These food wastes are usually flushed with water from hose pipes to the drainage. Where I've mentioned here toilets and even shower heads, these may not be directly used for processing operations, but they are mandatory in a food processing factory because workers require them, and workers have to be clean. Workers have to, these days, wash even their hands all the time. So you have these facilities, and they are part and parcel of the processing operation. So low flow toilets are preferred, low flow shower heads, yeah, and again where water taps need to be self-closing water taps. For example, when you use the tap, and when you finish, you should not be necessary then to bother about closing the tap behind you. It is self-closing, and we have a number of those now. And some are not very hygienic, especially in these COVID days, because you need to press that tap. The water flows. When you finish, sometimes it closes itself before you finish using it. Then you have to press again. So you press 3 or 4 times before you finish even just washing your hands. But there are better water taps, proximity sensing water taps, which many of us have come across. So here the water flows when, say, your hand is close to a certain sensitive part of that tap. And when you remove the hand, the water tap closes automatically. So this one is more hygienic because you don't touch the tap itself at all. And hose pipes use a lot of water, and small diameter hoses provide low flow and high pressure water that results in water saving. Now, there are other measures that can be taken to save water in a fruit or vegetable processing factory. Manual removal of fruit and vegetable wastes and residues from floors and equipment before use of cleaning water saves water. So you immediately begin using water if there are large pieces or huge piles of wastes and residues that can be removed manually. I've already talked about small diameter hose pipes, but these hose pipes should have manual trigger nozzles. Manual trigger nozzles that regulate the flow rate. That is manual control of the flow rate, and automatic shut-off valves. Automatic shut-off valves, so that as soon as you stop using that hose pipe and you drop it down, it automatically shuts off the water flow. Cleaning of processing equipment immediately after use minimizes the water used for cleaning. So this is due to the fact that product residues do not become dry and crusty on the surfaces and harder to remove and pre-soaking of equipment and flows, loosens dirt and hardened food residue. As it that has been used recovered and reused or recycled in the same process operation of washing water by straining or filtering to remove solids and using a pump to recirculate the water back to the washing process. It saves water. This may be the initial stage of washing. For example, pre-rinsing of the dirty equipment. And this is then followed by the use of cleaner water, or indeed clean water. But the reuse of washing water may require treatment of that water to meet the hygienic requirements. So there may be need for ultraviolet or ozone treatment of the water before it is reused. In washing operations, where now we are talking about washing of food materials, washing of fruits and vegetables, the use of countercurrent product washing approach, where rinse water and the product flow in opposite directions, is recommended. So in this system, the dirtiest water is used for the first rinse, and clean water is used for the final rinse. And it is reckoned that this can save up to 40% of the water used in the once through washing system. Another water saving measure is recycling of final equipment rinse water for initial rinsing or intermediate rinsing. Now, where we have advanced operating or processing systems, where we even have an evaporator, which is a special processing equipment for evaporation of juices, so that we end up with a juice concentrate. The heating is usually done by steam, and there is steam condensate, which should be returned to the boiler, as I mentioned earlier. But there is also condensate from the evaporated water. The water vapor is condensed, and that evaporator condensate should not be discarded. It can be used in the same factory, for example, for equipment pre-rinsing and pre-soaking of dirty surfaces before cleaning to save water, because instead of using fresh water supplies the evaporator condensate can be used, but there are not many processing factories that have evaporators. So it is a special unit. Now, this is the countercurrent cleaning system that I mentioned above, where clean water comes into contact with a clean product that is leaving the washing system, and the dirty product is in contact with the dirty water. So you have water moving from left to right, and the dirty product is introduced on the right hand side unit, at the extreme right hand side, and then moves in the opposite direction. That is why we talk of countercurrent flow. Now, to facilitate reuse or recycling of wastewater, it is important to segregate the wastewater. Segregate wastewater from various units, because the wastewaters from various processing units have different solids contents and or bacterial load. So the cleaner waste streams can be reused directly without any further processing, any further treatment, and the dirtier ones may need special treatment. Yeah, and treatment, I talked about ultraviolet and ozone systems, but there may also be special filtration technologies, such as ultrafiltration and reverse osmosis. Now, as I conclude, I mention processing plant design for efficient water use. So the water use efficiency should not be an afterthought, that the processing plant is designed and installed, and then when the operations begin, then the operators or the managers then start thinking about how to save water or how to increase the water use efficiency. So the efficient water use should start at the design stage. So therefore, some processing plant designs are inherently more inefficient than others. So one must therefore properly consider the water use efficiency of the processing plant that is being designed before any purchase is made and before the machinery and equipment are installed. There should be a very, very thorough consideration of the water use efficiency. And just in short, there are 6 design principles. So one is to design for ease of cleaning. Design for ease of cleaning, or what is referred to as hygienic design. So if processing equipment is not properly designed, it can be very difficult or even impossible to clean it. So if you have a tank with a flat surface or with a pipe protruding at the bottom, protruding into the product, it will be impossible to completely drain that tank because it is not naturally draining, and some of the cleaning liquid, or indeed even some of the food material that was in that tank, will remain at the bottom at the end of the cleaning process. So design for ease of cleaning. Number 2, we are ensure there is adequate metering, sub-metering, and process control. Adequate metering, sub-metering, and process control. Here we are talking about water metering. So we have to include the necessary water metering systems in our processing plant design. And 3, design to use dry methods for cleaning and transport. Design to use dry methods for cleaning and transport. So where possible, dry methods should be used. For example, in product cleaning, raw material cleaning, there are dry methods. You can remove some of the contaminants on the raw materials using methods that do not require water. Those are the dry methods. And dry transport means that we do away with the water fluiming that I mentioned earlier, that where possible, avoid the use of water for transport of the food materials. And next, you use product and byproduct recovery systems. Use product and byproduct recovery systems in the wastewater. That is product and byproduct in the wastewater. So if you have a way of recovering these, then there will be less requirement for water, for example, for cleaning of these materials. And design for water reuse and recycling. So if you want to reuse and recycle water, there may be need for special water treatment facilities, for example. These have to be designed for. It should not come as an afterthought that once the factory is already in operation, then you realize you need to install something. You need to install, for example, a UV treatment plant. Yeah, because now that, of course, will now require money that perhaps was not planned for. It may require space that perhaps does not exist in the factory as designed and constructed. And last but not least, design for water use. Design for minimal or no water use. Quite often, there are options. Whenever you want to process a food product, there are options when it comes to the type of equipment or machinery that you can use. And in selecting the appropriate equipment, one must consider the water use efficiency. If you have 2 or more options, then you should preferably go for those that do not use water at all. Now, if that is not possible, then go for those that use very little water. So that water use should be one of the criteria for selecting processing equipment. There are many other criteria that I do not want to go into. And the bottom line is that it should be economically feasible. So if it uses no water or very little water, but it's extremely expensive, then of course it will not make any sense to go for it. So one must not be one-dimensional, that when you are thinking about water, you are only fixated on water use. There are many other factors one takes into account. Again, like before, it is necessary to always monitor, to always measure. Yeah, it's important to measure and to record the quantity of water used on a daily basis, and also the production, the tons of the product. Yeah, so that you can be able to compute the quantity of water used to produce 1 ton of product or 1 kilogram product, and so that you can also compute the cost of water per ton or kilogram of product. I think my presentation ends there. Is there any question or comment?
Yeah, any question or comment, whether online or here physically?
Any question or comment? Has anyone tried to measure water usage? Those who are processors here, and also those who are online. Has anyone have experience of managing water use in a processing factory? Yes.
No, the online people need to hear you.
Oh, the online.
Yeah, I was just saying, I never have thoughts of measuring processing as a small scale, as a cottage industry. But of course, try to put to be very efficient.
Yeah.
And I'm just wondering, do we have a measurement tool where you don't need to keep running, for example, to the meter to see how many meters? I'm just thinking, for example, let me use an example of fish. It comes in, clean it, right? So I'm just trying to ask myself, vegetables,
That is one way of estimating. Sometimes measurement here really means estimating. Estimating to the best of your ability. So once you measure once the flow rate of water from a tap, say when it is fully open, then you can subsequently merely time that tap. Know that yes, it has been used for 5 minutes. And once you know the flow rate, because you have measured it once, you assume it is the same, and you can calculate how much water has been used for that operation. If it is a sink, there is an inspection fitting at the bottom, which you can disconnect so that you can collect the water when that sink is being used in the normal way, so that you know that when it is used for so many minutes, so much water is used. It's the same thing with electricity. Of course, there is also a meter, APLC. If you generate your own electricity, then you should install a meter that measures the entire electricity consumption. But you can go further and do sub-metering so that you can determine how much electricity is being used by each processing section or each processing unit. Now, some electricity, that the advantage we have is that the machines are rated there are nameplates on machines that will indicate the power rating of that machine in kilowatts or in watts or in horsepower. And you can assume then that that is the power consumption of that machine when it is running. And all you need to do is to time the machine. At the end of the day, you will say that machine X was in operation for 2 hours. The other machine worked for only 1 hour. Another one worked for 6 hours. And from the power rating of each machine, you can estimate the electricity usage by each of those machines, and you add them all up to get the total electricity usage. Any other comment or question? So, Duke,
Yes.
I hand over to you.
Okay, thank you. Thank you very much, Prof. So by now we should be coming to the end of today's presentations, especially on waste management. That one will be taken by Professor Mdama. And I guess as processors or consumers, whatever cadre you are learning something, right? So we move to the next session. Sorry, we lost internet a bit, but I guess we're back now.
Yeah, thank you. Thank you very much, Duke, and good morning, ladies and gentlemen. We are now going to go into another important area, and this is waste management. And as you have heard, my name is Mdama from Wangari Institute and Environmental Studies, the University of Nairobi. Now, this subject of waste management is actually a very important subject, and it presents many opportunities for us, especially in this sector. So we'll start by just looking at what we already are aware of. Now, when we talk about waste, there are very many words that are used to describe it. You can talk of rubbish, refuse, garbage, and others. Indeed, this is a word that in any language around the world, you will have a similar word. As much as it is a concept, it is something that is so close to humanity in that regard. So there are those different words depending on the processing. Now, of course, we have different types of wastes, and broadly speaking, we have the so-called biodegradable, and we also have non-biodegradables. When we talk of biodegradable, we are talking about the waste that can be biodegradable, such as fruit waste, agricultural waste, paper. In the non-biodegradables, the class of now plastics, yes, and the cans and others. So those two broad types are important. So basically, when we talk about waste management, we are just talking about how we handle the waste. It can be either disposal, it can be recycling, it could also be changing it for alternative use. Yeah, and that all that will be seen as waste management. So of course, waste can be, you may want to talk about waste in terms of either liquid, solid, and it can also be in gaseous form. So there are those three broad areas that we can look at. So specifically for MSMEs, we industrial wastes, we are basically looking at particularly fruits and vegetables. And these are materials that are removed from the fruits and vegetables during certain processes, one of them being cleaning, or even processing or cooking, and also packaging. Yeah. Now they may include several categories. We may talk about leaves. We may talk about peels or skins. You may also talk about the pulp or seeds, and even the spoiled fruits and the vegetables can be in that category of industrial waste. Of course, connected now to the market, depending on your market, there could be some trimming, that is shaping or sizing for that attractive visual appearance, and that may produce waste. Of course, there is also that aspect of transportation that could also bring about waste products, and sorting, especially for an example, supermarket, to meet certain quality standards. So there are those that will not meet that standard, may be seen as waste. And of course, again, if you want to maintain high standards, there are certain elements that you may want to consider, be it shape, be it color, and so on. And you end up with waste. Of course, you also now have the outgraded, or misshaped, wrong shaped, and so on, especially for quality and standards of the given buyers. So all these are considerations that will lead now to waste. Because you also note that there will be water. We have just covered the water area. That would also be part of this waste, industrial waste. So we want to have some, to touch on a few examples of good practices. And we start with management. And I need to start from the onset that globally speaking, actually the concept of waste, and I'll use the example of Sweden, and this is an example that you can quickly Google and confirm. Sweden is now at 99% recycling efficiency. In other words, Sweden is actually importing, and I've just Googled, and they are importing 800,000 tons per year of waste for their energy. They import because they already see the value of waste from other countries in Europe. Yeah. So you can imagine that huge opportunity if that possibility is available in the city of Nairobi, because waste is a resource. So instead of looking at waste as a refuse, there is that rethinking that it is actually a resource. Now, here we are starting with waste prevention, as one of the management options. And this, of course, offers the greatest environmental benefits. And of course, you save in terms of costs. So you prevent the waste. How do we do this? Of course, the first thing is to commit to establishment of a waste reduction goal in basically 4 broad areas. So this has to be planned. So one of them is reduction of waste. Another one is reusing materials, reuse. And then there's also donation or exchange, and that would be possible of materials. And then, of course, it's now the recycling. So these are 4 broad areas that are important. And it is interesting that, of course, there is some activity, especially in Kenya, regarding some of these areas. And I was looking at GG to see whether there is any business that is going on in terms of exchange, in terms of recycling and reuse. As much as this is not very evident, we have other countries around the world where this is catching up as a business. So this requires us to do several things. One of them, of course, like now we are looking at the example of transport. There is the possibility of switching to reusable transport containers or purchasing in bulk. Yeah. And then we bring in, of course, what we covered yesterday, establishment of an environmental management system. It's a possibility. And of course, when we talk about the environmental management system, we are saying that we need to start with our policy, yeah, and then we need to plan for it, and then we go implement it, and then we can see what needs to be improved. So if it is in terms of waste management, then we start with that policy for the organization, and we would want to see that at least we are gradually reducing. And because it is about continual improvement, then it is possible for us to save in terms of costs and make headway. Of course, very briefly, because this was covered, when we talk about environmental management system, you see, it helps an organization to manage and improve its environmental performance. Yeah. So that management and improvement of environmental performance, and here we are talking about really managing the negative impacts, and also helping to increase resource efficiency. That becomes important. Of course, it also helps in complying with the laws and regulations, and importantly, also it generates financial savings, well-managed use of resources, and efficient practices. So there are savings that come with it. And of course, another important one is the improvement of the reputation of the organization because of that environmental performance. So this is a selling point to buyers one way or another, whether locally or internationally. And then a final one is, of course, adapting to changing environment. This has been mentioned earlier on by different ones of us, because this is an important area that needs to be addressed. And the example, of course, here being like climate change. So this is to help us just identify when we talk about the waste management hierarchy. At the lowest is disposal. Yeah. And then you can recover energy. Yeah. You can do recycling. You can actually reuse. You can minimize, and you can prevent. So, for example, the example I've given for Sweden, they are using the waste for energy. Yeah, energy production. And it is, for them, it is actually very efficient because talking about 99% use of their waste, and they now import so that they can meet their energy needs. It's already something that is really an example that we can think about. So we start with now the reduction of waste. We want to touch a few things on reduction of waste. So here we are talking about can be either prevention or minimization. You can minimize, of course, reuse. So we are talking about redesigning products or pattern of production so that at least there is reduction in the waste that we are producing, depending on whatever it is that we are producing. Yeah, so this aspect of reuse of products and packaging, of course, prolongs the useful lives of these materials and it delays the final processing. So the reuse is basically, instead of disposing immediately, it will be used for a prolonged period for the benefit of not only the organization, but also the environment. So when we talk about reuse, we can also look at it in terms of either repairing, furbishing, or washing, or even simply just recovery of worn or used products. And here we are talking about, especially in transportation, that we produce materials that can be used in their boxes in transportation. Yeah, and even for shipment. Yeah, so that they are not they can be used more than the usual. Then of course there is this concept of donation as a good practice. Of course, studies tell us that this is happening, especially in the city of Nairobi, where we are seeing, especially products for exports, whenever they don't meet certain standards, they may be donated to children's homes, and other needy families, so that now, instead of it becoming waste, then there are those benefits. And of course, there is also the element of a possibility of advertising surplus and reusable items. And also, of course, this can also be done through commercial material exchange. I want to demonstrate an example. Here now we are talking about segregation, and this is at the University of Nairobi, the College of Agricultural Sciences. Basically, segregation here means that we can identify where we want to put the biodegradables, the non-biodegradables. Here, in this particular one, we have parts separately, we have plastic separate, we have organic waste. Yes, and we also have glass and metal. The colors, of course, are the standard colors that are used generally globally. I would like to mention that before we did this, of course, as a college, we are paying for the collection of waste. And I think the last time I checked before the COVID, after we started now the segregation, particularly on the paper alone, there was a revenue that was reported. I think about over 100,000 shillings that was received. Previously, we were actually paying for this to be collected. Now, this is money that is coming in, and that is just on the paper alone. So there are benefits that segregation can bring on board. Recycling. Yeah. So we one way is, of course, increasing program efficiency through employee education. Yeah. Of course, we also need to have tracking and evaluation of internal recycling activities. Yeah, and of course, we also need to expand collection by 1 or 2 materials each year. So those are elements that are important. So of course, the awareness now becomes important, so that whatever it is that is being seen as waste, how do we handle it? Because it is of value to somebody else. We should not ignore. We should actually be careful to know that it can actually be converted into usable product. Yeah. Then here we are talking about whether we are considering paper, we are talking about plastics, or whatever it is that we have. Then we see it in that context of being a resource. Yeah. Yeah, of course, we also need to investigate external markets for recyclables, yeah, so that we can see whatever we have, is there somebody else who needs it? And how can they get it? And that becomes important. Of course, when we talk about the opportunities available in waste management, we are listing several of them. One of them is composting, yeah, so that we get manure for crop production. Yes, we can also get reusable packaging. We can also get fuel. I've used that example of fuel, particularly for Sweden. And then there's the production of biogas. And this, of course, there are activities in Kenya on biogas. And these are opportunities that one may want to consider. So what do we need to do? I think there's need for that commitment to manage waste. This requires, of course, top management to be committed, to see waste exactly as a resource. And similarly, the way we have talked about energy, we have talked about water. You cannot manage something that you don't even you have not measured. Yeah. So there's need for audits. How much waste is your organization producing? Say per day or per week. Yes. And in what form? What proportion is organic waste? What proportion is organic? And so on. Because that becomes important. We need to know the types of waste. And yes. So we need to find a way, a simple way of measuring. Yeah. And we also need to know the human effort that is needed for waste management. Of course, here there is a cost-benefit analysis. We may put some extra effort, and there will be returns on that kind of investment. Yeah, and of course, we need also to be conversant with the policies and regulations regarding waste management. And that way, now we can identify strategies to reduce or recycle waste. And of course, from there now we can have action plan. I want to thank you. This is an opportunity for each one of us. So the waste that we see generally, particularly in cities, is actually an opportunity that we are seeing. Whether now we look at it at micro level or even at macro level. Thank you very much. I open the floor for questions. Thank you.
Thank you, Prof. We learned something on waste management.
So any question? Or suggestion? Yes. Yes. Let me give you the mic.
Even without directly connected to regular week care, the question is we can the country that other countries like the rich country or waste you people look for at the top scientists and sometimes back I saw that trying to do the whole stuff. But is there a way to resolve the problem? Is there a way to is there a way to advise them about the production of energy from the waste material, the coal that is being because the biggest whatever us not directly connected with less plastic because the level what we talked about 20% of the levels from waste to the waste so it's quite good.
Thank you. In my considered view, it is actually directly connected to what we are doing. In this sense, that the waste that we are producing is beneficial to somebody else. So we need to bring that other person on board. There is somebody who is in the energy sector, who is producing energy, and may benefit from what we think we don't need. Yeah. How now do we attract them? And I hear you. We are doing our part as researchers. What is this part? Is to provide the information to the policy and decision makers. So that is already happening. We already have industries. We have organizations that are dealing with the plastics. Like now you have talked about the poles and even tiles. Yeah. So they already know that when they get plastics, this is what they are going to do. But you see, we need to connect. Who is this who has produced the plastic and where can they take it to that other person who can produce usable products? So we need that network, yeah, so that we do not work as silos. So this is not actually outside. It is actually directly connected because it will mean that we are generating revenue for the organizations present, and we are also being more efficient in what we are doing, and we are getting benefits for the environment. Thank you.
Yes. Any other? Oh, yes.
I just wanted to add to what you said and help address my doubt. I think the biggest challenge, there has always been a disconnect between research and implementation. Because research getting what they require, but then how do they relate it? Or how does it come to the people on the ground? So whether it goes to policy, somebody started, that's the end of the story. So there has been a very big disconnect, and it is being bridged by more customer informed. So you are informed, you know you can go to the institution and ask, what can I do? Right? I also look at it from the agricultural police. They will do this, you will have the cargo, you will have the universities. But what is the farmer doing? They're still planting the same old things, the same old potato. Because that linkage of how do they take that and give it to the farmer to be able to then better. Right? But like I said, with knowledge and transfer of information now, people knowing that you can relate with them and makes you a better person. So for me, it's we as industry then helping by practicing what you learn. And then most importantly, impacting it.
Okay.
And then that helps you again do the now the entire policy. Is the production of high protein for animal feeds to come down from the competition that we are having between fish feed and natural for animal feeds and for human consumption. Today you can actually convert your biodegradable waste by putting it to something where it's a capsule. But again, you're converting all that waste and eating yourself and that also takes
Thank you.
Okay. Thank you very much, Prof. I guess, yeah, that is it for now. Give this to you.
So we finished earlier than scheduled, and we need to make a decision for those who are here physically. For those who are online, I hope you didn't have any clarification or question Is there any question for those who are watching us who are streaming live? You can type that question, you can make that comment. Do you see any?
Not really. There is a look at the chat, but there is none at the moment. It's fine.
Okay, since I don't see any hand raised, I want to believe that we are okay online. Okay. Oh, somebody was saying they were not hearing the question. I think it was a comment where there was a discussion between research and practice and how waste can now be utilized, especially when it comes to animal feed. So the participant had made a comment on use of waste in production of black soja. I think we have one of the processors in this project who is doing potato chips. We have visited her company in around KU. She actually uses the waste, and that is now what she gets out of the process. Yeah. Yeah, it is called Gaia Foods Limited. The last time we had an online conference, she actually presented it very nicely. So for those who are online, we want to thank you for joining us. I think now